Record too. Okay, we'll start at like 42, but yeah, if you guys just want to look at the puzzle and if anyone has like admin questions, I will try to answer them. But yeah. Yeah, I'm really bad at visual puzzles, so I like looked at it for a really long time, actually. Okay, does anyone want to share their answer? Yeah, just either one of you can go. Yeah. Yeah, nice. Okay, cool. Hi. Okay, so I guess we'll start. I'm Rachel. I'm a backend TA. So today we're gonna be, Today we are gonna be talking about HTTP, REST, and Postman. And I know like for the previous project, you guys interacted a little with all these things too. So we're just gonna do like a high level overview of that. But before we start, does anyone have any questions about anything? Okay, cool. So I'm just gonna start with like a high level overview of HTTP and then, oh, sorry. Okay, yeah. So yeah, HTTP bracket S is the language of the internet. It's how you basically like move data across like the server and your front end and your back end. So I guess to start, we can like go back to this like image and like if anyone wants to like give a basic breakdown on like the difference between like a back end and a front end, that would be cool. Okay, yeah.
Front end is like what the user sees, and it's I think like kind of like the outer part of what they interact with, and like backend is what allows them to like
Yeah, exactly. So if you guys didn't hear that, she just said like the front end is like what the user sees, and then the back end is like all the data things going on. So basically how the front end and the back end interact is HTTP. And if you guys are wondering like the difference between like, HTTP and HTTPS, it's basically like the S means like secure socket. It's like encrypting the information that travels. Other than that, they're the same thing. Yeah, I don't know if you guys like have seen when you're at like a HTTP website and then like the browser has like it's like grayed out and it looks like angrier for some reason. It's because it's not secure and they're saying that your data could be getting like stolen in transit. Okay, so that's what HTTP stands for. Yep. So as I was saying, it's used to communicate across the internet, and computers are making HTTPS requests to each other, and it's being processed and yeah, by a laptop, and a response is sent to us from the server. So that is HTTP as an overview. So as I was saying, the bottom HTTPS and the top is HTTP, where HTTPS just has a secure socket where it allows your data to be encrypted in transit instead of like an insecure connection, which is the top thing, right? Yeah. So now let's look at requests. I think you guys might have interacted with requests, and there's like a bunch more, but these four are like the four that are always used. So let's do like let's imagine a database, right? Like, let me think. Like, imagine I am a bookstore. Okay, so I want to get like all the books that I have in my inventory, and all my books are stored in a database. For example, like MongoDB or like AWS, right? So a GET request is basically saying like, I want to get all information on this thing that I have in the database. Yeah, so therefore GET. Post is saying that I want to give information to the server / the database. So in a lot of instances, when you do like a post request, you have like a header and a body, where the body is like, I'm gonna give the server more information or like more data that it needs to be like storing. Yeah. And then put is it replaces all the current representations in the database. And then delete is just deleting the thing that you're saying to delete. Yeah. Okay, so let's look at it like in a concrete example, right? So so these like backslashes are routes. So basically what's happening is I am going to be like, hey, at this route, I want to do this specific request, where the request can be like any of these things, right? So let's like think about it. Like if I say to my books database, I'm like, I want to get books. What should I be getting in response? Okay, cool. So you just get all the books in your database. Does that make sense? Okay, cool. Okay, so then we look at the second example where it's books / book ID, right? Where like that curly bracket thing is basically like saying I can put any ID in. So like, for example, if ID 1 links to like the physics textbook or something, if I put like 1 in there, it will bring back information or like do the request of the information of book ID 1, which would relate to the physics textbook in the database, right? So what happens if I call a request to this route, like books / like 1? What happens to the physics textbook in the database? Yeah, exactly. So yeah, pretty straightforward. The word tells you what it does. So we are deleting that book ID of 1 from the database. Okay, so the next one is post / books. Does anyone want to guess what happens when I send a request to post to this endpoint? So just like, yeah, go ahead.
So like, you get the post URL from the site, and is that how you get the database?
There's a GET request. So a post request is you are adding a book into the database. So like I mentioned before, like post requests would have like a header and a body, whereby the body is you adding things into your server or your database. Cool? Okay, and then let's do a put request. Anyone has any idea? Yeah.
I had a question.
Yeah.
When you call get or book, would that return all the books in the database with also with their specified ID number?
Yeah, so basically like your endpoints return things in the way that you set up your database.
Okay.
Yeah, so for example, like if I set up my model, which is like how I interact with my database, in a way that like the response object is a JSON with like all the information, then I will get all the information. So it's basically how you set it up.
Okay.
Yeah. So a put request of a specific book ID, for example, the physics textbook, what it does is it updates a book. So for example, I like have the physics textbook, and then like as you were saying that there can be other information on the book. Like for example, I want to remember that I have like 5 of the physics textbook in my inventory. So if I do like a put request, what I can do is I can be like, yo, somebody bought this physics textbook. And then I can say like, I want to put now 4 instead of 5 of the physics textbook into my database. Yeah, so yeah, that makes sense. Okay, so the last one is we're doing like a get request to books, but we want like a specific book. So this is also kind of like a setup thing of how you set up like your routes to get the information, right? So in this case, like this insinuates that I want to go into my books database and get a specific book, which means that my server will respond with all the information of that specific book. And that is different from the first one where I'm doing get books, where it returns all the books in my inventory, right? So yeah, just one book instead of all the books. Does anyone have any questions about requests? Yeah. Mm-hmm.
So creating a book, how does that get you?
So like posting means I'm like imagine it's like mail. I'm posting you mail, right? So in this case, it's like I am posting you all this information on a new book that we just added to our inventory. Does that make sense? Okay, yeah, go ahead.
If you like delete a book,
Mm-hmm.
I mean, or does everything like share or like never mind. I think is it like an array or sorry, I was like hearing it.
Yeah. So like I understand what you mean, because like if you think about it in like a Excel or like a SQL database, you just imagine like the rows should move up, right? But in a lot of cases, like it depends what database you use. So for example, like a lot of people use like MongoDB, and how Mongo works is it's like document based. So you don't really even maintain like row 1, row 2, row 3. It's basically like structured like a tree so that it searches instead of like looking at a specific index. But that's like database setup, and I think that's like 186. I'm not sure. But yeah, it depends how the database is set up or like how it's built to like fetch your data. Does that make sense? Okay, cool. Any other questions on this? Okay, cool. So now let's look at responses. So like I mentioned, like HTTP is me speaking to the server in a lot of instances, right? Where the server is like my data of like I'm trying to figure out like what to do next, or like where to put the data, or like what information do I need to carry on to the next like thing on my website. So your server has to give a response to you when you do any requests, because if not, like imagine when you like code like I want to get all my books, and then nothing happens, right? Like you don't know what's wrong with the server. So that's how we mediate this. Like every server will give you a response, and you don't even need to like think about that, because this is just how servers are set up. Sorry, this is kind of small, but there's basically like 100, 200, 300, 400, and 500 responses, right? And really, like you don't have to know them, because you can Google it, but like there's things that you always interact with, right? Like if you get like a 404 error on a website, it just means that like we don't know what's happening, and like the website is not found. So like I'm pretty sure we've all reached like a 404 error. But what you do have to know is like a 200 response means that it was fine. That means the server got your request and it sent you a response. Yeah, so I guess like other interesting things which we've probably seen before too is like 500. Like when you get a response 500 error, it just means that's like an internal error. And a lot of these instances is like the server doesn't know what's wrong either. It's just like, oh shit, like that didn't work, right? Yeah, so those are responses. And in a lot of cases, let me see if I can. Sorry. So if you like inspect your thing, you can actually like see some of the network happening, right? Oh, there's nothing happening. That makes sense. Sorry. So basically like when you send a request to the server, when the server responds to you, it comes back in a JSON object, which we will talk about later too, where in the JSON object, it has to tell you a code. Like it just has to tell you one. If not, you don't know what's going on and you don't really know how to like carry on with your code. Yeah, so that's responses. Does anyone have any questions? Cool, yeah, I think responses are pretty straightforward. Okay, let's talk about making a request. So in this setup, what's happening is we are making a request to the Pokemon API, right? So the top one is your terminal, and then the bottom one is just keying this into the browser. So how many of you guys have seen like curl before? Yeah, so curl is like, how should I put this? So like, for example, if you have your terminal open, right? And you wanna like download like Ruby on Rails, right? In theory, you could like curl the website endpoint and it will download onto your browser. So when you like download things, for example, you can like curl it, which is using a terminal, or you can like download a graphical interface, which is what a lot of us interact with, right? Like, you know, when you like download things on your Mac and then they like open a whole interface where you like keep pressing next and you agree with all the terms and conditions. That's basically what curl does in certain instances when you're downloading things, right? So the point of this is to say that curling an endpoint URL is exactly the same as going to an endpoint URL. So let's just like go to this real quick, right? I don't think I have. Okay, yeah. So have you guys ever like went to websites and it just looks like that? So basically what's happening is I am going to the endpoint and the endpoint is returning me this object. So I'm asking for all this information and it's giving me it back in this JSON object. Yeah? Okay, cool. Sorry, my mouse is. Yeah, so that was what the point of this was, is to just say that your machine also has a built-in way of calling endpoints. So I have any questions? Okay, cool. So let's look at an anatomy of a request. Now, like even everyone on their laptop right now, if you like take a look at the URL on the top of your browser, like there's something going on there, right? And basically, like it can be broken down into a HTTP request of what's happening. So let's look at the first thing. Like I mentioned, like HTTP is the protocol where S is with the secure and then HTTP is not the secure one. And then the next thing is the host, which is basically where I'm gonna look for my server. And then resource file, we'll talk a little bit more about that later, but that's basically a setup thing also. It depends how like the engineers or the developers or the architects like set up the website to get data, right? And then the question mark is the start of the query string. So for example, I want to, for example, I'm like looking for a graduation dress, right? And I like want to filter my searches. And I want to say like, oh, I only want to see things that are like less than $500, right? Because that's insane. So what's going to happen is that it will basically send a URL where there'll be a question mark and then there'll be like max price equals to 500. So in this case, what is happening is that it's going to like the content section and it's looking for a resource with ID 1 and topic 2. So imagine like your query string can be like hella long. You can just keep appending like every n is a new variable that they're like searching for when you're calling the server. So like, yeah, you guys can look at a URL right now and it will probably be formatted like that. Okay, cool. Okay, so the next thing is JSON object. So like I mentioned just now, so this is a post request, right? This is a full-fledged post request. Like instead of this is like what the user would see. But what's actually being sent to the server is this, where like I'm gonna specify a method, which is one of the request types that we talked about earlier. And then the URI, which is where the endpoint is, and then the protocol, and then there's this like bunch of immediate like header information that is like necessary for looking for like correct things in the server, right? And then the last part, the body part, is what I was talking about just now, where we are sending the server information. Because for example, even if I wanted to get like a GET request, like I wanted a specific book, right? I need to tell the server which exact book I want. Like I can't just say I want book because there's like millions of books, right, in your database, presumably. So that's how you like send information, and that's a JSON object. And I actually don't know what JSON stands for. I think J stands for JavaScript. But basically it's you can think about it as like language agnostic. You really like it's not linked to JavaScript at all. So to be honest, like I just look at JSON objects as a huge dictionary, a huge Python dictionary, which really it is, where I can just like endlessly nest things, honestly, if I wanted to. It's not like best practice, but I can just keep saying like all the information I need to send to my server. So imagine Facebook, right? Like when you call for a request, it needs a lot of information to filter down to the exact return that you want. So all this information is going in the body and it's going to the Facebook servers, and then Facebook like filters it and then it returns you exactly what you want. Yeah, does anyone have questions about JSON? Let's look at, this is what JSON looks like. It really looks like a dictionary. Yeah, this doesn't mean anything, by the way. It's just wanted to show y'all the syntax of JSON. Okay, cool. We'll move on. So I just wanted to do like a quick like Node.js view of what like these requests look like in code, right? Because I feel like sometimes we're like looking at it at a really high level and it's really difficult to think about it in code. Yeah. So, okay, so this is, does anyone want to tell me what kind of request this is? Yeah. Yeah. Exactly. So this is a GET request. And yeah, I like it's kind of cheating a bit because it's using Axios, which is like a library that makes getting requests a lot easier. So in this case, what I'm saying is I want to get information from the to-dos endpoint. So in this setup, what's happening is that I have a to-do list maker, right? So this endpoint is saying that I want to go to the to-dos resource and just get all my to-dos. So like it, in theory, if you want to make like a to-do list, you actually are only like getting and posting information, right? Because that's really all a to-do list is. So I'm gonna get the information from the endpoint, and then res is my response object. And then I want the status, which is what we were talking about, right? Because if you get like a 500 status, it means that the server didn't do its job. And then I want to log the response, which would be like a huge body of JSON, like a JSON string. Okay, so then let's look at a post request. So like the structure of Axios is very similar and it's like really simple to follow. But if anyone has any questions, just like feel free to stop me. But what's happening is that in this case, I'm saying I'm gonna post to my same to-do list. But in this case, I am including a JSON body where I'm adding a to-do that is buy the milk, which is in this curly bracket. So this is the JSON body that I am posting to the server to add. And then the same thing, you want to like log your response to see like what the server is returning you. Yeah, cool. Okay. Okay, so I just wanted to like zoom out a little bit because I think like sometimes we get into like the nitty gritty and it's like, where does this fit into the whole architecture of like web development? So we're basically here, we're at like the first thing ever that a website needs, right? So what's happening is I'm sending a request which goes to my routes, right? So for example, like we talked about this like backslash is a route. So this is a route to like all my to-dos. Cool. So it's sending a request to my routes, and in like a traditional architecture, what happens is that your route like handles it and forwards it to a controller. So what the route is doing, for example, right, is like, if I got this, like this means nothing to my route. Like I need to parse the information to get like exactly what I need to do. So your route kind of handles all of that before it gets pushed to a controller, where the controller is the one that interacts directly with the server. Does it make sense? Yeah, because I think like when I like first started Node.js, it was just confusing because I didn't know where like things fit into the architecture of a website. So hopefully this is useful. Does anyone have any questions on like any of the boxes on the screen right now? Yeah. Yeah, for sure. So basically what you are doing is you're creating a separation between your HTTP request and your server. So it hits your routes, and then your routes calls the correct controller. Because like, once again, if we imagine like Amazon, right, they probably have like 1,000 or like 1,000,000 routes that you can go to, because they have so many things. They have imagine every single product is a different route. So what's happening is that in your routes, you are like parsing all the information and you're putting it into like a correct way. And then it gets pushed to a controller, and the controller interacts with the server or the database. Does that make sense?
So there's multiple controllers.
Yeah, there's multiple controllers. So that's also like a setup, or like a way, like if you want to like scale it, you kind of like have controllers for different things. So for example, I would have like a controller for interacting with like MongoDB database 1 and then MongoDB database 2, right? So it's like you kind of sort your controllers in a way that makes sense for your architecture. Yeah. Yeah, cool. And then I guess I'll just like briefly talk about the other boxes. So what happens is like views is your front end, right? So views is rendering your HTML. So what happens is the controller is like, I'm gonna get information, come back, and I'm gonna be like, what do I need to show the user now, right? Because in a lot of cases, like for example, I want to buy this product, but it's out of stock. The next view that I should see is that product's out of stock. So what happens is I get HTTP request, it goes into the route, it goes into the controller. My controller calls my database, and my database is like, there's no more of this product. And then it sends back the information to the controller. And then the controller is like, oh, there's nothing here. And the controller then has to look at a view of like what I should be pushing to the user. So then the controller is like, oh, there's nothing here. I grab the, this product is out of stock view. And then I push the HTTP response, which is the HTML page that the user sees. Sorry, that was very fast, but I think that makes sense. Okay, so this is like a basic graph of what it looks like. So this is another way of looking at it, right? Like where your middle portion is your business logic. Like I want to think about if I was like building a shop website, right? I want to think about like what that middle portion is going to do that makes sense with my business model. Yeah. This one? Yeah, exactly. So imagine like your views is like HTML rendered pages of all the different things that the user would see, right? Okay. So does this business logic portion make sense? Because this is like when you like intern and like work, they will like always tell you to do things that relate to business logic, and it always doesn't make sense. Yeah, so I hope that's clear. Okay. So just the last thing I wanted to like talk about briefly is like, how does all of this relate to like how you structure your code, right? Because in a lot of cases now, like you're thinking about all these moving parts, like all these moving parts are happening, right? Like imagine one request goes through this entire chain, and we need to think about it in a sense that like it's our code that's handling this entire chain, right? So like a lot of people have like different ways in which they structure their folders for like HTTP requests, but like this is an easy way to look at it in my opinion. So I don't know how much of it we should talk about, but what's happening right now is like all your routes go into your API routes folder, so that it's like every time your root hits your code, it goes to the correct place based on how your folder structure is set up. Yeah, this will make more sense when you like do it and like create an API. And then the rest of it is a lot. But like it's also dependent on like how you want to set up your code. And yeah, that's it. Does anyone have any questions? Yeah. Yeah, so this is how like in a lot of cases you handle like requests, right? So what's happening is that your front end is kind of connected to app.js, which is your entry point of your entire website. Yeah. Actually, this is like doesn't have like views and stuff, which you would integrate with your front end, but I just wanted to show like a typical backend framework. Okay. Cool. Let's take a break for like 3 minutes, and then we'll come back, and then Amira will take over. Cool. For anyone that just came in, you can do this visual. Shit. If anyone just came in during this break, you can not take a break and look at it. Yeah, if anyone has any questions too, just let me know.
Like, I have my thing.
Oh my god. Oh my god. Where's it under? Oh.
I'm just gonna save like it on a folder somewhere on your desktop. You can delete it after.
Oh yeah, for sure. I mean, not a big deal. Okay. Oh, sorry. Did anyone wanna did anyone not hear the answer and wanna go? Okay, no, it's cool. The answer is B. Okay. Okay.
right, cool. Does anyone have any questions on anything like Rachel talked about? Anything we just covered, HTTP requests, any like intro backend stuff you guys are confused about, maybe where this ties in. If you have any questions or anything comes up, just like ask it anytime. And the first thing I'm going to talk about is something called REST API. And REST API is an acronym for RESTful representational state transfer. And you can think of this as basically just a style guide of how an API should be constructed and how data is transmitted. So you guys, again, like you don't have to memorize any of the stuff that I'm talking about right now. Again, these slides are always posted. The lesson's always up there. This is essentially, you guys can think of it as like a style guide on how to define and when you're building your own APIs and your own servers. I'm going to speak generally about this. You guys can look at it in more detail if you really want to. But essentially, what we really want to practice when we're building APIs is just separating the concerns of our server and our clients, making sure that we're handling all the information before we start querying requests to our database or like to whatever we're trying to pull data from. We want essentially, the data to be something called cacheable. And we also want to make sure that we're kind of designing our system in terms that all of the things that we want to get done are going to be handled on like different hierarchies. We don't want to be like combining things and like overloading like certain ideas or like one specific side of like one database or another. When you guys start building your own databases and servers, you guys are going to start getting more into this. But you guys can think of this as essentially like if you're trying to build classes, right? And you're just like regularly like programming, you definitely want to separate the concerns. A lot of people talk about the idea of like cars. And like when you're building a car, you don't want to have everything inside of like one class. You want to have like maybe like a vehicle object and then like a car object and then like a Honda object and then like 2018 Honda Civic object or something. You kind of want to separate your concerns. The same idea goes with databases and when you're just like building your servers, you want to have them so that it's easy to access information and everything can be kind of like passed around very easily and you're not overloading your server or doing things that are bad practice so that other people can't really use your APIs either. So we're gonna talk about Postman. And Postman is a super, super useful tool to basically help us test and validate our APIs. So Postman is a super user-friendly way to send predefined requests. So if we have like some server that we're trying to test out or that we built ourselves, and we want to kind of like test out the endpoints, a little bit of what Rachel was talking about. Let's say like we built some server, we're trying to like put some information in there, we're trying to delete some information, we're trying to get some information. How do we do all this without actually fully developing the server, fully like running it, building it? In the same way that we were designing our websites in React, we're not gonna design the whole thing and then like release it for the whole public to see, right? There's a lot of steps involved in that. Instead, what we're gonna do is we're gonna run it in our local machine, use our computer as the server, and basically get requests from our computer. So right now, what we're gonna do actually is build an API, create the own endpoints and what the endpoints are gonna return. And then Postman is essentially the middleman to look at the endpoints and test them out for us so that we don't have to actually deploy the database or like do it in the cloud. We can run it in our local machine, and Postman can actually test requests that are also stored in the cloud and also on your local machine, which is why it makes it a super useful tool. So we'll get into a demo. And before we get into this demo, I'm going to give you guys a minute or two just to download Postman if you don't have it already, which I assume most of you probably don't have it. But if you look on the slides, or if you just type in like Postman, let's see. Yeah, if you guys just type in like Postman API platform, just take a second to download this. I like to use it in like as a desktop app. You can use it on your web, like on the web version as well, whatever y'all prefer. But this is essentially how we're going to be testing our endpoints when we build them out. So just take a second, download it, or just like sign up and use it via the website. For now, I'm just going to use it. I'm going to use the website version to create my own requests, but you can do it however you want. Also, any questions on anything I talked about? Yeah. I'm not sure. I think you have to create an account to like actually start making requests. But yeah, you can just run through your birthday email. And then I'll show you the true power of Postman. Okay, awesome. I'm going to start talking. Sign up for Postman, download it if you haven't already, and we'll get to use it in a second. But I'm going to show you guys some pretty cool uses of Postman and what we actually use in the industry to like test out endpoints and get requests. So if you go to Postman, go to this like collections tab and click this plus bar here, it's going to open like some untitled requests. And why this is nice is because you can essentially like save files of requests. And if you're building a server or like building a database, you can pre-save like all your endpoints just to like constantly test them out and like go through Postman and manually test out each one. We're only going to be doing one at a time, so I don't necessarily like have to save a bunch, but that's also a useful thing. Like if I wanted to save this and I'd name this request name like test or something, and I would just save it to like some new collection. Then basically I would have some new collection here, and you can have a collection if you have like, you know, some different apps you're working on, and you would save essentially like one type of request. I'm just going to call it test for now, but I can, for instance, if I had like some database that was storing like a to-do list, right? I could have like one that was like testing like the get request for the to-do list, one that was testing like the put request, one that was testing like the deletes. So this is essentially just a super useful way to like store all your different types of requests and use them whenever and kind of like save them in Postman. Anyway, so we talked a couple of weeks ago about how a website is like given to you. Like when you click on a website, right? Or like when you click on a new page, how is that website like actually given to you? And what does your browser receive? And then how do they even understand like what to display? Right? If I look on like Google and I just want to type in like basketball or something, right? All these things are going to come up. Like how come, how come if I click on like this ESPN article, it's going, or like this, just ESPN.com, it's going to like load this for me, like load all the components, right? And essentially, if I copy this URL, I put it in Postman, let's just do a GET request on this URL and see what it returns us. Okay. And if you look at the bottom here, this all looks pretty familiar. We've done this before, right? You can see there's like some doc type HTML. There's like some HTML here. There's a head that contains like all this data. And then there's like some scripts here. We know what scripts are. There's a bunch of links. And then all of this like JSON data. We see like buttons here. There's a button that says skip to navigation, blah, blah, blah. This is exactly what happens when you're actually clicking on a website. So what your browser does is you click on a website your computer then sends an HTTP GET request to wherever that website's stored. So it finds the server, it finds where that website's stored, it goes to that server and it says, hey, I'm clicking on this, right? So get me the homepage of ESPN.com. And then ESPN.com, wherever it's stored in that server, is going to say, okay, yeah, sounds good. We built this React app. We have like a bunch of HTML here. We're going to send it back to you. So they send back all this HTML essentially in just like a JSON response. And then our browser then receives this like big JSON and all these like documents, this HTML and whatnot. And then we display it on our browser. So we just tested out live how to interact with the server just through Postman and like some generic server. Any questions on that, by the way? Yeah.
So the browser like undoes the JSON file and it also perfectly renders it.
Yeah, essentially. So what the Chromium, which is what Chrome uses to actually render all this information and render HTML and whatnot, it just builds your site based on the HTML data that it's received. So it asks for a document, it returns this HTML document, and then it loads the HTML document just based on the data it's given. If there's any like incorrect values, incorrect parameters, essentially just the page won't load. So everything essentially has to be working and perfect, which is why they tested it as well. When you're like building your own site, you test it out. And if it works on yours, like chances are it's probably going to work somewhere else, unless there are like some weird bugs going on. But yeah, that's what happens. You build it in your local machine, you deploy it somewhere to a server. Once it's out there on the server, if someone's like querying data from that server, getting that homepage, then it's going to return some response. Okay, so let's do something else. So a couple of weeks ago, Josh was lecturing and he talked about the NASA API and how if we wanted to like get some like API key or like store some like API data from NASA, we could do that. So let's say we wanted to like generate some API key. I'm just going to do this real quick. This is just for your own interest. You guys don't have to follow along this part if you don't want to. But say, okay. So now I just asked NASA for some API key, and essentially, some APIs, whenever you're like fetching some data from an endpoint, sometimes they require a key depending on if the information is like sensitive or not. So like maybe NASA wants to keep track of like who's actually like taking their data, which is why you have to sign up to get like a specific API key that's only given to you. But let's say like, I don't know if you guys have ever like, I'm just gonna like name this off the top of my head. Like if you guys have ever been on like Twitch or on YouTube or whatnot, every like streamer or like content creator has their own like key. And maybe like they don't want to give that key to anyone else because like other people can then start uploading like to their page or like start streaming on their account. So like they have their own key. And if they want to like publish that key elsewhere for like other applications to use and then gain access to their specific accounts, you know, they want to keep their key private and they're not going to share that key with anyone else. So some APIs, just like depending on if they're like information sensitive or whatnot, they don't want to give that key away, which is why sometimes you might have to pass in a key to when you're making a GET request. So here, you guys will be able to understand this in like literally 10 minutes. But what this is essentially saying is that, okay, we're making a GET request to this like endpoint here, which is some URL. It's api.nasa.gov/planetary/apod. I don't know what that means yet. And then we're a question mark is essentially we're passing in some like parameter type. The parameter type is API key, and we're giving NASA our API key. So NASA knows, okay, this is an authorized API key, therefore I can return some information to them. So let's go back to our test. Let's take that GET request, or let's take that URL and let's type it in the GET request, and boom, it returns like some JSON data here. And Rachel talked about what JSON data is. It's essentially like a dictionary. I believe JSON actually stands for JavaScript Object Notation, right? Yeah, I think that's what it stands for. It's literally just means like these are the objects, the types of objects that are used on the internet, and that we use to communicate from like one JavaScript file to another. So if we send a GET request to this URL, it returns us this JSON, and you guys can see like there's like some date here. There's an explanation, a bunch of stuff, URL, title, but where's this data actually coming from? So if we scroll down to the documentation section of the NASA API, we can see something called APOD, which is a key that's passed in when we call the GET request. And the APOD is astronomy picture of the day. And it returns this image. So if we look back at our GET request, we can see that the date is March 15th, 2022. I guess that's today. And the explanation is a very scenic road to the stars. The road approaches blah, blah, blah. And if we look at this picture, it doesn't have the description, but let's go back. It has this URL here. So if we click on this URL, oops. Okay, wait, let me just save this. Okay, if we click on that URL, that's what pops up. So essentially, we now know that APOD is just some key in the database of NASA that's returning some random picture of the day. And we know it does that because it returns some picture, it returns a description of the picture, and it also returns like the date of when we're asking for that picture, or like what day is that picture, the picture of the day, and also the title to that picture, which is A Road to the Stars. Okay, so this is pretty cool. We now can see that there are like a bunch of databases out there, and like a bunch of APIs, and essentially GET requests and HTTP requests are the way we interact with these servers and ask them for their information. Sometimes the servers might have some sensitive information, which is why we need to pass in an API key to get access to this information. But sometimes we can just call it as it is, and it's going to return some JSON data, which is exactly what's being returned when we call a GET request on just some base URL. So now what we're actually going to do is build our own server, which is kind of exciting. We're going to literally build our own server, deploy it on our computer, and then use Postman to interact with the server that's running on our computer. And everyone can do it. So, oops, I just closed Postman. Okay, so open up VS Code. And just make some folder like wherever you usually store your guys' like folders and files for this class. And then just create some JavaScript file called server.js. Okay, cool. Okay, now enter the folder essentially where you stored your server.js, and then run npm. Okay, wait, let me also make this a little bigger just so y'all can see it. Just run npm init. And essentially this is just initializing that folder to run all the like node like package dependencies and files that we want to install, and then run npm install express. Oh. Okay, yeah, sorry. I have to go through this. Okay, wait. Npm install express. Okay, and now we're going to install express, and I'll explain that in 1 second. Okay. I want to say it installs globally, but honestly, I'm not sure. I did this demo a couple months ago, and I had to install it then. And then when I was creating this demo, I had to reinstall it. So I think probably you have to install it for every like new project that you start. Yeah.
If I install it in the virtual environment, then would it not take memory since
You install it in a virtual environment. What do you mean by that? Like
contact
if you,
Like, it will only work in the environment. So you have to like activate the environment.
oh,
So like Postman does this thing where it like creates like a package lock. So then like every time you can just rerun it.
okay. Cool. So now let's type these lines in. Don't worry about exactly what this is doing, but just type in variable express equals require express. Okay, cool. Yeah.
When you're getting a express setup, I didn't perfectly you type in express because I saw you got the same maybe on
Oh yeah, you just essentially, I forgot, when you do npm init, it'll ask you a bunch of like information about your project. It'll say like, does your project need to have, or like, what's your name, description, blah, blah, blah. So just type in enter for all of them. It'll just ask you like a series of questions. Just type in enter and then it'll say, is this okay with a question mark? And you just, if you type in enter again, it'll say yes. It's essentially just initializing your project. And yeah. You mean like those, you mean the questions that ask you in the terminal for like npm? Yeah, I believe you can. I want to say you can honestly even do it in the package.lock folder. To be honest, when you're setting up a project, you only do it one time, and these things are usually irrelevant. You usually like set the name of like whatever you want to do in the metadata of your project. For that, I think it's just letting like npm know, and when others like install your project, what they're actually like looking into. And it'll show up actually, I think, in the document that npm install or like puts automatically in your folder. So I think you can change it there. You can investigate that though, but I'm pretty sure you can change it in the folder that it automatically creates for you. Okay, any other questions? So essentially, what we're telling our server right now, or this like server that we're building, is we have some variable express here that's requiring express. And so what we're telling our project is that we're requiring these libraries essentially, and we're pulling these libraries. It's kind of like an import statement for express. And you can think of express as essentially libraries that are used to like handle HTTP requests and to also like make requests to servers. And yeah, it's basically a library to do a bunch of things in the backend that are super useful, which is why everyone uses express to like handle, you know, creating servers, creating databases, manipulating them. Yeah. There are not import statements, I don't believe. I think this is essentially, yeah, this is the equivalent. There aren't any import statements when you're working on this. Okay, any other questions? Cool. Okay, so let's get to actually building our API. So we created this app by essentially saying we're importing Express here, and then we're saying this app is using like these Express libraries, and that's essentially how you initialize like some server or some API. So now let's say app.get, and what we're doing here is we're saying we have some API, we're calling it app, and then we're going to start writing get and put requests and delete requests. We're going to start writing all these HTTP requests for this API that we're building, so that when we want to like query data from this API, we actually are building the endpoints here, so that when we're interacting with our API, this is actually how we build those endpoints and what data it's going to like retrieve and what data it's going to send back to the person who's querying, or the machine that's querying the data. So let's start off with just a simple GET request. It's just a /, and then every time you create some HTTP request, you have to return some function, create some function that essentially takes in two parameters. You have a request parameter and a response parameter. And so what happens here is that essentially when someone is tapping into this endpoint inside of our API, which is just like some /, and what / literally means is just like, this is the base API. So, or this is like the base request. So whenever you're trying to like go to some home page, it'll always be like HTTP or HTTPS. It'll have like this 2 /, and then it'll be like facebook.com/something. So literally what this / is saying is that whatever you add on top of the base URL, this is what we're going to be returning. So you can kind of think of like just a regular / as like a home page, because when you type this in, it's going to return Facebook's homepage. So that's literally what this / is. It's like literally just get the information from the homepage of this URL that we're basically pinging data from. Okay, so what we're going to write inside of our function is we're going to write some response to send to whoever is querying our data. So we're going to send hello there. Let's close this out. Okay. So now what we just built is an endpoint that's essentially just like the home page of our endpoint. And what we're doing is we're accessing this response, and we're sending back a response that's saying hello there. So what this function that we're creating is, it's passed in automatically 2 variables when we're creating HTTP requests. The first is a request. So the request parameter is what users are using to request information from our database. The second parameter, response, is what's being passed into our function that we're responding to our user when they're trying to request data from our API. So you can think of this as essentially like this. So let's say we have our API right here. And then there is a user right here. So the user is making some request to the API. And the request that the user is sending has automatically some data inside of it. So when we looked at that NASA API, we requested the APOD. We had like some NASA URL /APOD. And APOD is a key in this database's in the API that we were requesting from. So APOD was the astronomical picture of the day, and that's what NASA created as an endpoint for people to use, which is why we had access to this. Another thing that we sent is another parameter, which was like some key ID or something, which is when we passed in our API key. So this APOD was essentially the endpoint, and we were telling NASA, hey, we want to get the information from this part of your database, which is like some APOD. So it's like, okay, cool. So now what the API is going to do is it's going to look through all its endpoints, and it's going to say the user is requesting, oh, this APOD request. If you have like 1 million requests from one API, you're going to have some name in order to like where you're going to be able to find your requests. So essentially, the API is like, okay, there's some APOD endpoint here, and they're passing in some key ID, which is what we're expecting when anyone queries information from NASA. And so essentially, what the API is going to do is, okay, the request is valid. So what we're going to do is we're going to send a response of some JSON that's going to, I realize this really isn't that big, but like, whatever. You have some request that the user is sending to the API, and if the request is valid, then the API is going to send back a response that's some JSON that essentially the user is now going to take, and it's going to do something with that information. So essentially, let's say we're like trying to build a website that showed, you know, the NASA API picture of the day every single day. So when let's say now that we built a website, and now this is no longer a website. Sorry, this is no longer a user's computer, but now this is our website that we built, and now we're storing somewhere else. So now let's say we have some user here. And what this user is now doing is it's going to get it's going to say, hey, let's call this website decalwdb.com. So the user is going to type in their website, or like in their like URL, Google, decalwdb.com. So they're sending an HTTP GET request to this website. And then this website's like, okay, what do I need to do here to send a response to this user? So we have like a bunch of HTML in here. And then one of the things in our like script inside of like some React app we built is that we're trying to show an image of this picture of the day and its description. So we have like some image tag, and we have like some text description underneath that we're trying to send back to our user and display it on their browser. So now what our website's going to do is, okay, let's go to this API, which is NASA. Let's request this information. Now NASA is going to respond with some JSON that we get, and we're like, okay, we have two values, which is essentially the URL of whatever that image is, and then the description of what that image is. And then we're going to respond to our user with our whole website, HTML and everything, and then inject this response into our website image. And then this is all going to be like compacted together in some JSON. And then all of these documents and metadata is going to be sent to our user, which then displays on their browser. So everything is basically GET requests. That's the end of that. Okay, any questions on what I just talked about? Yeah.
So this app.get, is this like a particular get function that you're saying, like, oh, if I get a slash, then that means I'm going to send out this hello there?
Exactly.
Have different types of get requests, like app.get, but you're gonna have a different route, I guess?
Exactly. So that's perfect, which is literally what we're about to do. And I'll show you in a second, but that's exactly what we're doing. We're just setting different endpoints, and we're creating different routes, is exactly what you said, to send to our user different types of information depending on what they want. You have a question?
Yeah. So you said the website that we create, getting information from API, sort of can act as an API for a different user that's accessing our website.
Exactly.
Okay.
Exactly. Yeah.
So then when a user is making a get request with /, automatically that this function is also passing the parameter here. So this function will already have the request field, like whatever the request to the user.
Exactly.
Now we're going to build this.
Exactly. Yeah. So when the user is querying this endpoint, which is just the /, they're automatically going to pass in their request. And then, or sorry, they're automatically going to send a request. And then in our response, we already crafted some response, which is like, hello there. And that's being basically, our function is able to take in a request, and we're also passing in a response that we're going to like then send to our user. Okay. this is all kind of abstract, but let's actually see this happen. So let's type one more line in here. And now what we're telling our server is that we're going to be listening on our local machine on port number 3000. So if I save this, and then let's run this. So let's do node server.js. Now we just started a server. And if we open up localhost 3000, we're going to see hello there, actually, which is like, whoa, that's pretty interesting because we literally just made this happen right here. And if we go to Postman, and then we actually type in localhost 3000. Oops. Let's do HTTP. Just type in this one. Oh, the course policy. This always happens with web apps. Do you have the okay. Okay, wait, give me one second. So essentially what happens sometimes is you might have gotten this error as well when you're like trying to access data from some API. Essentially, there's like this CORS error that's really common when you're trying to like send GET requests or just make any type of HTTP request from some server you're creating. If you type in your browser like require no CORS, there's going to be some documentation on like essentially how you can like override this. It's kind of a really annoying thing. Honestly, I don't even know what it is. It's basically just
It works when you get rid of it.
if I just did.
Yeah, only the local that for me.
Let's open up a new. Okay, whatever. We can just actually, we can like work with this in the browser, but if it works in your Postman, the desktop app, like I would prefer, which is what I use on my own machine. But yeah, just work with it, I guess. If you have the desktop app, if not, I can just show you guys in the browser what's actually happening. So let's try something else. So exactly what was suggested was basically, so let's say we have like multiple routes that we want to get information from. So now let's create another route. And instead of just having it as like the base URL, let's actually add some like key here where we're going to send some other information. So let's say weather. Let's say we have like some server that's like trying to, send back some weather information. And then it has like a database of like a bunch of like weather that we're storing in there. And then essentially we want to pull some weather data. So let's just say the response is it's looking pretty hot today. Okay, let's kill the server. You can kill the server by Control-C and let's rerun it. Oh, I need to save this. Okay. So now let's look at our website. If we go to localhost 3000, we're going to be sent back hello there. And the reason for this is because this is the base URL. we said in the base URL that we're going to respond with hello there, but now we're doing something different and we're adding another root, which is the weather key. And now we want to say it's looking pretty hot today. So let's go back to our URL. And at the end of this, let's type in weather. And we should get the response it's looking pretty hot today. If you do this in Postman, it'll do the same thing. It'll essentially return what we're trying to pass in. It'll return the response that we built in our API when we're trying to get this weather route. Are there any questions on anything that's or any? Yeah. Yeah. Do you mind repeating that last part? I'm not sure if I heard it. Yeah, essentially. So the reason why I can do that is because the app is listening on this port. So when I go into my browser and I'm typing in localhost 3000, essentially, I'm not too familiar with how the ports work, but there's like a bunch of different ports you can run your servers on. So you might have seen like 3001, 3002, 8000, 8080. These are just like some common ports to like run essentially this code like on your local machine and interact with your machine as the server. So on localhost 3000 is where you're running the server and you're querying the GET request to this endpoint, which is like localhost 3000/weather, which is then we're receiving this response. Sorry, do I have any ideas of what? The site cannot be reached. Do you have this code here? Did you initialize your like npm in that folder? Okay, maybe do you want to ask? Okay, sounds good. You can come up in a second after we do this. Okay, so now let's do something a little more interesting. So let's say we have like some data that's already inside of our server, and now we're actually trying to pull some specific information. We don't just want these like pre-written responses. We want actually some information that's being sent from our server based on what the user is inputting. So let's write another GET request. And this time we're going to use a special key. Oops. And then we're going to do /:ID. And so, yeah. Oops. Let's kill our server real quick. Does this look better? Okay, cool. Okay, so now what we're saying is let's create some endpoint, but what we're actually doing is the user is now going to send a GET request to our website, and they're going to pass in some ID. So we're saying whatever happens after the / is some ID number. And then we're going to send back some information based on the ID that they send us. So let's create another function here. We have a request and a response. And this time, we're going to send back a response, but we're going to say the ID that was passed in is the request.params.id. Okay, so what we're doing here is we're saying inside of this function we created, we're expecting or are anticipating that two parameters are going to be passed in: request and response. So in the request that's being sent to our server, we know that the user is passing in some ID. So what we're going to then send back to them is we're going to target that ID by saying, okay, we have some request parameter that's being passed in, and we want to access the params, which is essentially pulling whatever value is passed in to this request. And if you think of request, everything that's being passed to and from a server is all JSON data. So you can imagine request is like some JSON object, and inside this JSON object, we're then accessing the params, which is just like a bunch of like a sub JSON object of a bunch of parameters that can be passed in. I mean, the user can pass in, like, let's say, you know, they have like ID, names, whatever. We can add like multiple different parameters. And just to showcase that, I'm actually going to show you. Let's say we added one more semicolon here and we said name. So now we can anticipate two different types of parameters. The user may or may not pass them in, but we're expecting that the user can pass in some ID and they can also pass in some name when they're sending a GET request to our server. So we can say, oh, the ID is inside of the request JSON, and inside of the parameters JSON, we're accessing some key ID. And now that key ID that was sent in the request matches some value. And the value is actually what the user types into the URL. So now let's add something else into this response. Let's say we also want to get the name. And then let's say, again, let's look inside of the requests that are being passed in. Let's look inside the params, and then let's get the name that the user is trying to pass in. Okay. Let's run this. And now let's open our server. So everything else still works. The weather works. The base like endpoint works. And then the last thing is we're going to say, we're going to pass in some ID 123, and we're going to pass in some name. And then we can see here that in our response, we're sending back the ID, which is whatever the user sent as a request, the name, which is whatever the user sent as a request as well. And we're returning that in our response after this GET request. We're out of time, but you can imagine that you can essentially set up any kind of endpoints and with like any types of parameters that you guys want. With your app, you can set put requests. But one main thing we didn't talk about here is we're getting all this information, but what if we actually want to store information? What if we like want to keep track and we want to have like a to-do list, right? We don't want to just get information. We actually want to like have some database and actually send information there, store it, and then retrieve it later when we want to. So that's what we're going to be talking about in Backend 2, is how to actually set up a database and then query information from that database, store things in that database, and manipulate that database and do it in a way so that you can build websites and build really scalable applications. And that's all for today. Thank you. Let me just end the Zoom real quick so that I can give you all the access code. The Zoom network. Let's just. Oh. If not, it's all good.
I don't know when I know.
Oh.
You can just give the access code. I can
Okay,
give it.
okay.
I don't know what I'm doing. Oh wait, actually.
Okay. The access code for today is, let me give you a word. Get? Okay. Get. Thank you.
Where's the, oh my god, where's the bar? Wow, my laptop's. The whole bar is gone. I'm so confused. What am I doing?
Oh wait, here, this is why.
Oh.
Oh, shit.
Yeah,
That
do
was
that. Yeah.